Dear students, welcome to this networks class. So we have already started the introduction about this transport layer. I mean in the unit for the transport layer. I have posted the same as a video. I hope you have go through that video and all. So today in this class again we are going to start some introduction about this transport layer. Right, so regarding this class, we are going to, concentrate on the process-to-process delivery. That is, we are going to concentrate on port address and the mux and demux in transport layer. Right, so these are all the things we are going to see in this video. So, what is transport layer? It is the fourth layer of the OSI model, which is responsible for communicating from one system. Opening a process in one system and it has been communicating with the other system on the other process. So that is the responsibility of the transport layer. Say for here, a client system is opening here in our browser. When I am opening www.facebook.com, it is being passed through some router and through the internet it is being reaching the Facebook server. Right, so it has to open a service here, right, so that I can fetch or retrieve my data towards my client system. So this is the process, this is the responsibility of the transport layer. It will open the service or open a port at the server side, and also to get the data or to retrieve the data from the server towards the client side, it has to open a port at the client side also. Right, so this is called actually the transport layer responsibility. So here we have already seen this client server paradigm where for every communications it opens a port at the client side and also it opens a port at the server side. So this is how the client server paradigm works. Okay, so I know the IP address will communicate a particular system in a particular network. On a different network, an IP address is used to communicate or to contact a particular system which is present in a different network. So with the help of IP address, I could identify a particular system. With the help of port number, right, I can identify a particular process in a particular system. Right. So with the help of client server paradigm, this is actually possible. Okay. So addressing in the transport layer. This is the main thing we are going to concentrate in this video, addressing in the transport layer. At any time, at any mission, there is a need to deliver something. Please make a note. At any time, at any system, there is a need of delivering something to one specific destination, right? So I am going to deliver something from my client machine to some destination machine. Say for example, there are a number of destination machines are there. I have to select a particular destination machine and I have to transfer something. So this is the main concept or main objective of studying the network and all. So among many, so I am going to choose a specific destination among many and I am going to deliver something to a particular destinations. So for that, what I actually need is address. Right, we have studied a lot of addressing things in the previous unit. Say for example, in the second unit, data link layer, we have studied MAC addressing. And in the third unit, we have studied the network layer, and in case we have concentrated on IP addressing. So MAC address, right, which is used to communicate a particular device within the local area network. Within the local area network, MAC address is used for communicating a particular device. IP address, it is used for communicating a particular host which is present in some other network. And here, the transport layer, which needs a transport layer address. Here also addressing concept is being implemented here in the transport layer, which is called actually a port number. So as I said earlier, to open a particular service, right, at the other end, at the destination end, I have to open a port number at the server side, and also from my client side also I have to open a port number. So the main concept here in this slide is at any time, at any host, there is a data, there is something need to be delivered at some particular destination, right? Among many of the destination, I am going to identify a particular destination and I am going to deliver something. For that, what I actually need is address. So we have studied lot of addresses and all. MAC address we have studied, network layer IP address we have studied. Similarly, in the transport layer, we are going to concentrate on port address or port number. Okay. So what does it mean by port number? This has been chosen among the multiple processes running on the destination host. Right? I have to choose a particular process that has been running on a destination host. Among a multiple process, I have to choose a particular process that is being running on the destination host. So what is meant by destination port number? This is needed for delivering the data. And what is mean by source port number? This is need for a reply, right? When I am delivering something, it has to be replied, right? So that is actually for the source port number. So destination port number, it is needed for delivery, right? So from one end to the another end, I am going to deliver something, right? Similarly, the source port number, some reply has to come from the destination devices. So in the internet model, the port numbers are actually 16-bit integers. It has been ranging from 0 to 65,535. So this is the range of port number. It is a standard which has been present in the internet model. The port numbers. Okay. So this is the concept of addressing in the transport layer, right? So port number has been chosen among a multiple process that has been running on the destination host. So here we have to consider what is mean by ephemeral port number and well-known port numbers. So these are all the two port numbers that everyone who has been concentrating on networks has to know. What is mean by ephemeral port number? The client program defines, right, itself with a port number. Say for example, this is my system and I'm going to communicate with the Facebook server. So this is my client system, this is my server system. So as I said earlier, we have to follow the client server paradigm. So a client program which is running, say for example, I'm opening a browser here. That is actually a client program here. What here actually mentioning. This has to define a port number. So at my client system, I have to define port number that has been opened for a particular client program. This port number which I have been opening at the client side, this has been chosen randomly by the transport layer software running on the client host. Right? Please make a note, right? Randomly. So at a client side, if I am opening a port number, then that port number is actually chosen as a random port number, right? So at client host, if any port number is being opening, then that port number is actually a random port number. And what is meant by well-known port number? A server process must also define itself with the port number, right? So our ultimate objective is I want to communicate from the client to the server, right? I'm going to retrieve some data from the server and I'm going to do some communication between the client and the server. Okay. So for that, server also should open a port number, right? It has to define itself with a port number, right? A process which is opening here at the server side should also define it with the port number, right? Internet uses a universal port number for the server, right? Please make a note. If any process is opening a port number at the server side, then that port number is actually a well-known port number, okay? Or universal port number, okay? For the server, we can tell that port number is called actually a universal port number, but at the client side it has been called as an ephemeral port number. This ephemeral port number is being chosen randomly, but here at the server side it is actually a universal port number or a unique port number we have to open for a particular process at the server side. So now we are all questioning right, why the server cannot choose a port number randomly. So as I said earlier, client should choose a random port number. Server side, it should open a unique port number or a well-known port number, right? So this is called ephemeral port number, which is been opening at the client side. Here it is called actually a well-known port number. Here the question is actually why a server cannot choose a port number randomly. So this is the question I am going to ask here. So what is the answer behind this is, if the computer on the server side runs a server process and assigns a random number. So in case if I am opening a process here at the server side and I am assigning a port number for that particular process, you please make a note, process, for every process which is running on any system, it has to be assigned with a port number, right? So at client side it is random, but at the server side it is actually unique port number. Now the question is, if I am opening a process at the server side, for that particular process I have to assign a port number, right? That port number, if I am choosing as a random port number, what it will happen? What it will happen, the process at the client side that wants to access the server, uses its service, will not know the port number, right? So the basic thing is, as a client, I don't know what port number you have been opening there at the server side. So that is the reason I couldn't assign a I couldn't assign a random port number at the for the process at the server side. Okay, so the main reason is the client couldn't know what service is actually running there, what port number is actually the server is opening there. The client couldn't understand this thing, and hence I have to assign a well-known port number at the server side. So you all very clear, right? What is mean by ephemeral and well-known port number? Ephemeral port number, you please make a note. So it has to be assigned for a process, right? The port number has to be assigned at the process at the client side. Ephemeral port number, it is actually a random. But here at the server side, right, it has to be, the process has to be assigned, right, with a unique port number at the server side. I couldn't assign a random port number at the server side because the process at the client side that wants to access the server and also to use its service doesn't know about the port number which is being running at the server if it is random, okay. So and hence I am using a unique port number at the server side, okay. So example here I am presenting here. Say for example, there is a client and there is a server, and daytime client process can be used as a ephemeral port number. Here it is a temporary. So if there is a client, right, and I want to access a daytime client, say for example I want to access the current time from the server. So that is what we have been calling it as a daytime client and daytime server. So for that, if I want to access the current time, clock time, I have to access a particular daytime server, right? So for that I am opening a port number that is actually chosen at a random port number for a process that has been running at my client system. So through the transport layer it has been passed like, and I've been accessing a specified port number, unique port number that has to be open at the server side. So this is what I have shown here. A daytime client process can use an ephemeral port number, which is a temporary. This may be vary if I am using now, like if I am opening here now a process, right? So this may be vary at a different time, okay? So 52,000 to identify itself at the client. So daytime server process must use a well-known, which is actually a permanent port number. This is actually a unique port number that has to be open at 13. So say for example, there is another client, right? He or she also want to access the daytime server. Then a port number has to be open here. Maybe the port number 52000 some may be opened here, or 5200002 may be opened here. Right, a port number may be randomly assigned here, right? So it has been for accessing this daytime server, this should be very static, right? This should be a unique port number. For any time, for accessing the daytime server, for accessing the particular time, it has to contact the 13 port number at the server side. Okay, so this is the example for why we have to use a ephemeral port number at the client side and the well-known port number for the server side, right? So this is how the data has been communicated at the server, right? So this is actually the destination port number, this is actually the source port number, and it has been replying. This is the destination, a source port number and the destination port number. This is the data has been retrieved actually by the client. Okay, the time actually, because the daytime server will provide the time, current time towards the client. Okay. What is IP addresses versus the port number? So how it has been here relating here in the transport layer. So we all know destination IP address, what it will define the host among the different hosts, right? Number of hosts are there. I have to identify a particular host. Then what I need is IP address. So after the host is being selected, okay, I have been identifying a particular host among the different hosts I have been identified. So after selecting the particular host, what the port number will define is one of the process on that particular host. Okay, so there may be several processes may be running on that particular host. I have to choose a particular process that is being running on that particular process that has been running on the particular host. So this is the picture which shows that how the IP addresses and the port numbers are being related here. So at the network layer, with the help of IP address, I am identifying a particular system at the destination, right? And in that particular destination host, I am identifying a particular host. So this is the particular host that I am going to identify. So this has been happening at the destination. I mean maybe a server. Okay. So this is how the IP address and port numbers are being related. So okay, what is IANA port number ranges? We are going to discuss here in this slide. Internet Assigned Number Authority, that is called actually IANA, Internet Assigned Number Authority, right? It is a sector where I mean it is an organization where the users being assigned. I mean it is used for assigning the port number for the various customers or clients. Okay, so there are three ranges of port numbers. As I said earlier, there is a well-known port number, and there is a registered port number, and there is also a dynamic port number. So you can relate here, well-known port number is nothing but your unique port number, right? Unique port number. Okay, so where the server is being assigned with this kind of port numbers. And dynamic port numbers, this is also called as a private port numbers or ephemeral port numbers. We can call it as an ephemeral port numbers. And there is a port number called registered port numbers. This has been ranging from 1024 to 49,151. And it is not assigned or controlled by IANA. They can only be registered with IANA to prevent the duplication. So it is for the registration, future and everything registrations. This has been called as a registered ports, and hence we are going to use the well-known port numbers at the server side and dynamic or private port numbers or ephemeral port numbers at the client side. So this is actually ranges from 49,152 to 65,535. This has been neither controlled nor registered. Okay. So this can be used at any process at the client side, and this is also called as a ephemeral port numbers. Okay, you please make a note. There are three ranges of port numbers which has been defined by the IANA: well-known port numbers, registered port numbers, and dynamic port numbers. So dynamic port numbers, it has been assigned to the client side, and this is the well-known port number. This has been assigned, our unique port number that has been assigned to the server side, right? This can be chosen randomly at the client side, right? And what is mean by socket addressing? So socket addressing, what is mean by socket addressing? We have seen in the previous two slides before, we have studied what is IP addresses and port number. What is the relation between the IP addresses and the port number? Here the same thing we are going to see as a socket address. So process to process delivery needs two identifiers, as I said earlier. One is the IP address to identify a particular host among a different host, and the port number, I'm going to identify a particular port number at the destination end among a different ports that has been opened at the other end. So the combination of the IP address and the port number is called actually socket address. So please make a note, this is a very important thing. A combination of an IP address and a port number is called actually socket address. The transport layer protocol needs a pair of socket address, right? Definitely it needs a pair of socket address. One IP address, port number, another IP address, and another port number. So why? So client socket addresses defines the client process uniquely. So I want to identify a particular process that is running on the client side. Then I need an IP address of the client and the port number that has been opened randomly opened at the client side. And similarly, I need an IP address, another IP address at the server side, and a particular process that has to be opened uniquely at the server side, right? So server socket address and the client socket address. So pair of socket address I need to communicate a client and the server. Okay. So yeah, this is the IP address, right? And this is the port number. When we have been separately, we can call it as an IP address and port number. If it is been combining at the transport layer, then we can call it as a socket address. Okay, socket address. Okay, what is mean by the multiplexing and demultiplexing in transport layer? It is a very simple thing, right? We have only one transport layer protocol, that has to be used at any time in a particular system. So at the sender side, if you are considering at the sender side, there are a number of processes that needs to send a packets, right? There may be running several number of processes at the sender side, right? Which is indeed intent to send some packets. So this is called actually many-to-one relationships and request multiplexing concept, right? So very simple thing. So at the sender side, several processes are running here, right? So but I'm having only one transport layer protocol at the sender side, right? And hence I'm using a MUX concept here. I'm multiplexing all the process that is been running, and at the network layer, right, with the use of IP address, I'm sending the data here. The protocol accepts the messages from the different processes differentiated by their assigned port numbers, right? After adding the header, the transport layer passes the packet to the network layer. So this is happening at the sender side. So at the receiver side, here the relationship is actually one to many, right? One to many. So I'm here combining all the process at the client side. Here I am diversifying all the received data towards a specified process which is running at the other end. So the transport layer receives the datagrams from the network layer, right? So this is the transport layer. So and this is the network layer, and it receives the datagram right at the transport layer. After error checking and dropping of the header, the transport layer delivers each messages to the appropriate process, right? So it has to deliver each and every data to a particular process based upon the port numbers, right? So this is happening at the receiver side. So sender side, right? Sender side, I am doing my MUX, that is actually many-to-one relationship. Many process running, and I am converging it with the help of multiplexer, right? I am sending the data. And at the receiver side, I am here using the concept of demux, right? One-to-many relationship is here happening here to deliver particular data to a particular process based upon the port numbers at the receiver side. Okay, so this is called actually multiplexing and demultiplexing. So very simple thing, right? What we have studied is actually we have studied a very important concept, ephemeral and well-known port numbers. This is a very important concept in the transport layer, port numbers. So, and we have studied what is IP addresses versus port numbers, and IANA ranges is also very important. So we have three port numbers: well-known port numbers, registered port numbers, and dynamic or private port numbers. Well-known port numbers, which is also called as a unique port numbers, that has been assigned at the server side. But in case of client side, we have been randomly choosing the port numbers, right? So this is the thing we have been studying here in this video. And if you want to do some analysis in this port number, you can go to this website. So right, where you can check, right, what are all the different services which is been running in your system, and what are all the transport protocol port number which has been registered accordingly. Let's say for example, as we seen in the example, right, daytime server, at the server side 13 is the port number which uses TCP protocol, right? So only two protocols has been using here, TCP, UDP, and maybe sometimes SCTP also, right? So these are all the left side, it shows the different services that is been running on the system, and these are all the unique port numbers that has been opened at the server side. So you can view, right? So every pages, it consists of port numbers and their services. Okay, so every port number, it has its own services, right? This has been, say for example, you can go for say for example, you can go for HTTP, right? HTTP 137, you can view HTTP 138, okay, 36. A lot of processes actually running here, right? So you can view, and you can check what are all the services running, right? Everything you can check. And that's all about this introduction, right? We have studied right, so these two things, port address and MUX and DMUX. Thank you.